Assalamu alaikum. Welcome to lecture number 12 of Software Design and Architecture. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, what we studied in our last lecture, if you remember, we see design a two-part process where we see how conceptual design is actually different from the technical design, and we also see how design is basically a two-part process which actually bridges between the customers and the system builders, and we also see the difference between conceptual design and technical design. And then we see how architecture is earlier than the detailed design, and we discuss in detail architecture addresses the non-functional requirements and the detailed design actually addresses the functional requirements. And after it, we see the architecture business cycle, and we also see how architecture business cycle actually influences from different perspectives of stakeholders, developing organizations, environment, and the architecture experience. And we see how architecture actually influences from these environmental factors, and we also briefly explain the process or a cycle of architecture business cycle. And then we also see different challenges being faced by the architectures, like different stakeholders have different concerns, and all of these stakeholders had different kind of influences, and all of these influences are how actually deal by the architectures to address in its architecture. So where we also call the how much architecture job is a difficult one. And the last one, we see the different architectural activities involved in the architecture business cycle. So students, it's a little bit recap about our last lecture which we studied in our lecture number 11. So let's start the formal discussion of our lecture number 12. So students, these are the brief objective of our today lecture discussion. In this lecture we see what are the different contributory factors which are involved toward the software architecture, and then we also see the different kind of roles of software architect, and then we will see how architecture actually addresses the non-functional requirements and how it can affect on software quality as well. So these are the brief objective of our today's lecture discussion. So first of all, here is the different contributory factors which actually plays a important part in software architecture, like software quality attributes, IT environment, human dynamics, business strategy, and the design. All of these factors are contribute toward the software architecture. So let's discuss these factors one by one. First of all, the quality attributes. As I said earlier, quality attributes refers to non-functional requirements of the system, and non-functional requirements are addressed by the software architecture. What kind of quality attributes I am talking about? Like reliability, availability, portability, maintainability, efficiency, effectiveness, performance, reusability. All of these are the non-functional requirements which comes under the umbrella of quality attributes, and these quality attributes must be addressed by the software architecture. And the next one is the IT environment and the human dynamics. IT environment mean the what kind of tools will be used by the software architect, what kind of environment actually it is where the system or where the software architecture will be built, like either the software architect will be utilized a web based or object oriented or desktop based application. All of these comes under the in umbrella of IT environment and different human dynamics as well. So here the background experience and expertise or domain level knowledge is also involved in this human dynamics as well. And then there are different kind of business strategies. So what are the business strategy in the software architecture? Basically in the business, we have to build a business strategy in software architecture, which actually is a set of competitive moves and actions which actually tells us how a business uses to attract its customers and how it can achieve its organization goals. So what kind of organization goals I am talking about in business strategy? In business strategy, actually we are trying to achieve our organization goal, like we want to achieve, make a business strategy like low cost product or a timely delivery or a not often changing requirements. All of these are come under the umbrella of business strategy. And then the design, obviously we are discussing from last 10 to 11 lectures about the design. So about the design, you are well aware about the design. So all of these are the five factors which are the contributory factors toward the building of software architecture. So now in this lecture, we in the previous lecture, IT environment, different human dynamics and the business strategy are already discussed. So in the architecture business cycle, where we also see the environment, the human dynamics and the business strategy in the category of developing organization, and design is also being discussed from few slides from few lectures as well. And now in this lecture we will discuss briefly about the quality attributes. So let's move towards the next slide. So before we move toward the quality attributes, I would like to discuss a different role of software architect. So students, there is always some roles of software architect which we need to understand. Like there are four different kind of roles, like design expertise, domain expertise, technology expertise, methodological expertise. All of these are the different roles which are actually performed by the software architect. I will explain you these four different roles one by one. So basically, a software architect provides a solution that the technical team can create and design for the entire application. So a software architect should have expertise in these four domains or four fields, which we also call a four different roles of software architect. Let's discuss these roles one by one. So first of all, the design expertise. So what would be the design expertise of software architect? Like expert in software design, like including diverse methods and approaches, like such as object oriented design, event driven designs, different kind of modeling techniques. All of these are come under the umbrella of design expertise. And this design expertise of software architect lead the development team and the coordinate development effort for the integrity of the design. सो स्टूडेंट्स, इस डिज़ाइन एक्सपर्टीज़ के अंदर क्या आता है कि जो हमारा आर्किटेक्ट है वो डिज़ाइन डिफरेंट सॉफ्टवेयर के डिज़ाइन में एक्सपर्टीज़ रखता हो। जैसा कि आप हमारे पास ऑब्जेक्ट ओरिएंटेड टेक्निक है, वेब बेस्ड टेक्नोलॉजीज़ है, कोई इवेंट ड्रिवन मॉडलिंग है, कोई फंक्शन ओरिएंटेड अप्रोच है, स्ट्रक्चर्ड प्रोग्रामिंग अप्रोच है। ये डिफरेंट डिज़ाइन की एक्सपर्टीज़ हैं जो सॉफ्टवेयर आर्किटेक्ट के अंदर होनी चाहिए, क्योंकि वो डिज़ाइन एक्सपर्टीज़ का भी रोल प्ले करता है। सो इट्स ऑल अबाउट द डिज़ाइन एक्सपर्टीज़। एंड द नेक्स्ट इज़ डोमेन एक्सपर्टीज़। सो व्हाट इज़ एक्चुअली डोमेन एक्सपर्टीज़? बेसिकली डोमेन एक्सपर्टीज़, like software architect need to expert on system which is being developed and plan for software evaluation. It also need to coordinate the definition of domain model for the being developed. So in the domain expertise, you can say that the architect should have what kind of project he or she already done in the past, what kind of experience he or she have, what kind of in what kind of architecture or what kind of or what kind of previous history he or she have a knowledge about the specific project. So it's all about the domain expertise. And now the next one is technology expertise. Like that, in the technology expertise, our architect must be aware about the different technology level implementation details as well. Like उसको पता होगा प्रोग्रामिंग लैंग्वेजेस सेलेक्ट कौन सी करनी है, कौन सा फ्रेमवर्क यूज़ करना है, कौन सा प्लेटफॉर्म यूज़ करना है, और डेटाबेसिस का डिज़ाइन कौन सा चूज़ करना है. सो दीज आर द टेक्नोलॉजिकल एक्सपर्टीज विच मस्ट बी हैव इन द सॉफ्टवेयर आर्किटेक्ट. सो टेक्नोलॉजिकल एक्सपर्टीज इज़ द आल्सो वन रोल ऑफ सॉफ्टवेयर आर्किटेक्ट. तो जिसके अंदर सॉफ्टवेयर आर्किटेक्ट कोऑर्डिनेट करता है थ्रू सिलेक्शन ऑफ प्रोग्रामिंग लैंग्वेजेस, फ्रेमवर्क, प्लेटफॉर्म्स, डेटाबेस डिज़ाइंस. ऑल ऑफ दीज थिंग्स are actually covered in this technological expertise. And now the last one is methodological expertise. This is the fourth role of software architect. So in this methodological expertise के अंदर ये एक्सपर्टीज़ होनी चाहिए कि सॉफ्टवेयर डेवलपमेंट लाइफ साइकिल क्या है, और SDLC के जो डिफरेंट प्रोसेस मॉडल्स हैं उन प्रोसेस मॉडल्स के अबाउट कौन सा मॉडल्स की डिटेल्स क्या हैं, कौन सा मॉडल्स कब यूटिलाइज करना है, लाइक वाटरफॉल, स्पाइरल, इंक्रीमेंटल, आइटरेटिव, स्क्रम, अजाइल, ऑल ऑफ क्रिस्टल क्लियर प्रोग्रामिंग. ऑल ऑफ दीज आर डिफरेंट process models. So our software architect must have internal details and knowledge about these process models so that he or she can choose the appropriate model for the development that ultimately helps the entire team. So students, these are the four different roles of a software architect which we discuss in detail. So except these four roles, there are some hidden role of software architects are as well, which are not a formally role, but these are sometimes also being utilized in this SDLC as a hidden role. Like a software architect can be share different knowledge, or he or she software architect can protect the team member from external forces, like which distract them and bring less value to the project. So all of these kind of politics can be involved in the SDLC process as well. So there are some hidden role of software architects are well, which are not the formal roles, but these are the informal hidden roles are as well. But these four: design expertise, domain expertise, technology expertise, and methodological expertise, these are four roles which are the formal role of software architect in the development of any project. So let's start with the some quality attributes. Like there are some quality attributes which ultimately leads towards a good architectural design. Or in other words, in this now in coming slides, we will see how non-functional or quality attributes will ultimately lead to a good architectural design. Now let's discuss these non-functional or quality attributes one by one. So students, the first one is efficiency. So basically efficiency usually refers to the responsiveness of system. Efficiency हम क्या कहते हैं कि हमारा सिस्टम कितना रिस्पॉन्सिव है, हाउ मच एक्चुअली इट इज़ रिस्पॉन्सिव, या इसको कितना टाइम लगता है कि अब हमारे किसी इवेंट का, किसी स्टिमुलाई का रिस्पॉन्स करे, उसको हम क्या कहते हैं, एफिशिएंसी। कि हमारा सिस्टम इतना एफिशिएंट है, आप उसको एक टास्क परफॉर्म करने के लिए दें तो वो आपके उस इनपुट के अगेंस्ट, उस स्टिमुलाई इवेंट के अगेंस्ट आपको जितनी जल्दी रिस्पॉन्स दे रहा है और कितना आपका जल्दी रिस्पॉन्स दे रहा है, तो आप उसको कहते हैं कि दिस सिस्टम इज़ टू मच एफिशिएंट। तो फर्दर हम देख सकते हैं कि जो एफिशिएंसी है, जिस इसको हम इन इसके इवेंट्स को फर्दर थ्री पार्ट्स में डिवाइड कर सकते हैं। लाइक first, time is needed to communicate between, first one is time which is actually needed to communicate between different software components, and the second is the computation time. First one is the time needs to communication, and the second is computation time, where is a concern about how the components executed or may have overlaps or gap between them, and the third one is the times which are needed for each component to complete its computation. So there are these three different kind of events which are comes under the umbrella of efficiency. First one was the time which is needed to communicate between different components, and the second is computation time, that components executed, and the last one is actual time that are needed for each component to complete its computation. So these are the three different sequence, or you can say it's a different sequence of events which we divide into these three different categories. So ultimately we can say that architectural design play a key role in determining the performance of the software in terms of efficiency. So let's discuss the correctness. So as the name suggests, it is very basic. सो व्हाट इज़ द करेक्टनेस? सो करेक्टनेस क्या है? करेक्टनेस एक प्रॉपर्टी है कि हम हमारा जो सॉफ्टवेयर है, अगर वो स्पेसिफिक यूज़र की रिक्वायरमेंट्स को करेक्टली इंप्लीमेंट कर दे, सो वी टेल आवर प्रोडक्ट इज़ अ करेक्ट। सो ये हमारे लिए पास इम्पॉसिबल है कि किसी भी लेवल के डिज़ाइन, किसी भी लेवल के ऊपर अगर हम अपने डिज़ाइन को करेक्टली इंप्लीमेंट ना करें, और वो हमारा अगर हम अपने डिज़ाइन के फेस के ऊपर अपने यूज़र की रिक्वायरमेंट को करेक्टली डिफ़ाइन ही ना करें, तो हम कभी भी करेक्ट इम्प्लीमेंटेशन की तरफ जा ही नहीं सकते। सो करेक्टनेस इज़ वेरी इंपॉर्टेंट। इफ़ and only if it is possible that a design at any level that does not correctly implement the specified requirement would lead to a correct implementation. So it's all about the correctness. And the next one is the reliability. So students, what is the reliability? You must know about the reliability. Actually the ability of a system to behave as it is specified within an environment or within a time. reliability क्या है कि कोई सिस्टम ऐसा ही काम करे जैसा करने के लिए किसी इन्वायरमेंट के अंदर, किसी मखसूस टाइम के अंदर करने के लिए उसको बनाया गया है, तो इसको हम कहते हैं reliability. So we can say that reliability is the probability that a system perform user required functionality at specified environment in a given period of time. सो रिलाइबिलिटी को हम मेजर भी कर सकते हैं, डिफरेंट मैट्रिसेस अवेलेबल हैं, लाइक मीन टाइम बिटवीन फेलियर, like probability of failure on demand, like availability and so on. So these are the different reliability metrics. So reliability is the also important quality attribute which ultimately leads to good architectural design. And now the next one is portability. So students, what is the portability? क्या है portability? हमारे पास ये है कि जो सॉफ्टवेयर सिस्टम है हम उसको कितना इजीली शिफ्ट कर सकते हैं, ट्रांसपोर्ट कर सकते हैं वन हार्डवेयर या सॉफ्टवेयर के प्लेटफॉर्म से अदर हार्डवेयर या सॉफ्टवेयर के प्लेटफॉर्म के ऊपर। इस कॉन्सेप्ट को कहते हैं पोर्टेबिलिटी। सो बेसिकली वी कैन से दैट पोर्टेबिलिटी इज़ अबाउट हाउ much it is easy to ship or transport a software system, hardware or software to another platform. So this one we call the portability. Like for example, from a personal computer or Windows environment to a Sun or a Unix environment or a Macintosh Apple environment, how much it is easy for us to transport or ship ourselves from one platform to another platform. This concept we call the portability. And the portability is also an important aspect of good quality design. So students, we can say that a well structured design should group environment dependent into a small number of components so that the change on the code to move another. So it's all about the portability. So it's clearly well defined about the portability. You can easily understand about the portability. And now the next one is maintainability. As students, what is the maintainability? Actually, maintainability refers to the modifiability, how much it is easy for us to modify of our system. So maintenance is very important for any project which ultimately leads to a good architectural design. So now the question is, there are four different types of maintenance as well. So what are these type of four maintenance? Let's discuss these four types of maintenance very briefly. So the first one type is corrective maintenance. So what are the corrective maintenance? In corrective maintenance उस तरह की maintenance को कहते हैं जिसके अंदर हम modifications या updation करते हैं या उन errors को या उन problems को fix करते हैं जो user project के install user end के होने के बाद जो errors को identify करता है, उन errors को अपडेशंस को प्रॉब्लम्स को रिजॉल्व करने को हम कहते हैं corrective maintenance. And the adaptive maintenance is actually this kind of maintenance where we update of our software product or in the environment of constantly being changed, or whenever the new business environment is actually taken place. This kind of maintenance we call the adaptive maintenance. And the third one is perfective maintenance. So we can say that perfective maintenance is a type of maintenance where we have a new feature or a new user requirement where we have to refine our software to improve the reliability and performance attributes of our system. We call this type of maintenance a perfective system. जब हमने कोई न्यू फीचर को, न्यू यूज़र रिक्वायरमेंट को अपने सिस्टम के अंदर इंस्टॉल करना हो अपने सॉफ्टवेयर को रिफाइन करने के लिए, जिसके थ्रू हम रिलायबिलिटी और परफॉर्मेंस को अचीव करें, इस तरह की मेंटेनेंस को कहते हैं परफेक्टिव मेंटेनेंस. एंड नाउ स्टूडेंट्स, द लास्ट वन इज प्रिवेंटिव मेंटेनेंस. इट्स अबाउट द फ्यूचर. In this type of maintenance we are actually concerned about the maintenance where are we are more serious, we are concerned about the serious issues which will be may come in the future. So preventive maintenance is about the future. So students, these are the four type of maintenance which are actually involved in the maintenance attribute. So now here in this diagram you will understand how much a maintenance is cost and how much it is important. You can see that the 33% cost is the total development cost for ranging from the requirement to testing, and while the 67% cost is the maintenance cost of the entire software development life cycle. So in this diagram you can conclude that how much cost of the maintenance is. So 67% is the total cost of maintenance in the SDLC, while all other SDLC phases only cost 33%. So we can conclude that the maintenance cost is higher than all of the other SDLC phases, and it is the total 67% of the entire SDLC. So it's a huge cost, and there are four different type of maintenance which we see. So we can conclude that maintainability or maintainability level quality attribute of any software architecture require a lot of cost to resolve this maintain different kind of maintenance. So now let's discuss the reusability. So reusability is also another quality attribute of any good software architecture. So reusability is self explanatory. Like, reusability is the property of a system which actually is about how much it is your components can be easily reused, or it can be developed of this order software system. Like, we can say that like, if such architecture can be used in a series of application in which we can utilize different reusability level, like different components, different product lines, these are different reusability approaches. So we can reuse again and again this structure or architecture, which ultimately help us to increase our productivity, which can be significantly improved. सो रीयूजबिलिटी क्या है कि जिसके अंदर हम अपने सॉफ्टवेयर सिस्टम के डिफरेंट कंपोनेंट्स को, आर्किटेक्चर, स्ट्रक्चर, स्टाइल्स, पैटर्न्स को रीयूज़ कर सके अगेन एंड अगेन। और स्ट्रक्चर को, आर्किटेक्चर को जब हम रीयूज अगेन एंड अगेन कर सकें, मिडल वेयर्स को, आर्किटेक्चरल स्टाइल्स को, पैटर्न्स को अगेन एंड अगेन रीयूज़ कर सकें, तो वो हमारी प्रोडक्टिविटी को क्या करते हैं, इंक्रीज़ करते हैं। हम रैपिडली मार्केट में डिफरेंट प्रोडक्ट्स को डेवलप कर सकते हैं, बिकॉज आवर आर्किटेक्चर इज़ मोर रीयूजेबल। जितना आर्किटेक्चर हमारा मोर रीयूजेबल होगा, उतना रैपिडली, उतना फास्ट आप डिफरेंट आपकी जो प्रोडक्टिविटी है वो इम्प्रूव होती जाती है। सो इट्स ऑल अबाउट द रीयूजेबिलिटी। एंड नाउ लेट्स डिस्कस द इंटरऑपरेबिलिटी, विच इज़ द लास्ट एट्रीब्यूट ऑफ आवर दिस लेक्चर about good architectural design. Basically, interoperability is about how much easy for a software system so that it can be used with other software system. Interoperability ये होती है कि हमारा जो सॉफ्टवेयर सिस्टम है उसको अदर सॉफ्टवेयर सिस्टम के साथ यूज़ करना कितना ईजी है। सो लेट्स इंटरऑपरेबिलिटी जो है मोस्टली डिपेंड करती है इंटरफेस के ऊपर, किसके दरमियान, सॉफ्टवेयर सिस्टम्स एंड इट्स इन्वायरमेंट। सो लेट्स डिस्कस दिस इंटरऑपरेबिलिटी विद द हेल्प ऑफ एग्जांपल. For example, I say students, the interoperation of a word process with an image processing system requires that the result of one software system, for example, such as image processing of a photo, can be used so that a document can contain both text and image content. So it's all about the interoperability, where we see how a software system can be used with other system. Like, we see how we can utilize a word processor with some image processing tool as well. Or we also see how a document can contain both text and image contents. Like, text is all about the word processor, and image content is coming from the image processor. So these are the two different operations. So these are the two different applications which are actually operation between each other. So in interoperability, we conclude that actually we see how much it is easy for a software system so that it can be used with other software systems. So interoperability is the most important thing as well. So students, still here we discuss different quality attributes which ultimately leads toward the good architectural design. So students, still here we also discuss some other quality attributes in more detail with some more examples and with more classifications as well in our coming lecture. So students, still here our lecture number 12 is ended.